Good morning to you all. Today I will be discussing about the secondary treatment of wastewater and specifically about the trickling filters. So let's start. So first of all, I would like to tell you about the primary treatment and the secondary treatment. So primary treatment basically deals with the removal of the large objects like the plastics, rags, leaves. So the process is here. First of all, the raw sewage is coming from here side, and the first is the screening. The large grid of metals are placed whereby the plastics, leaves, rags are separated out from the wastewater. After that, if something any large passes through this screening process, gets into the comminutor where it gets smashed or break down into the small pieces. After that, there is a grit chamber. In this grit chamber, the suspended solid particles get settled at the bottom under the influence of gravity. Then comes the primary clarifier, where the sludge of the primary treatment gets settled under the influence of gravity at the bottom. After that, the treated wastewater, if it attains the permissible limit, is flowed into the river, and if it do not attain the permissible limit, then the secondary treatment occurs and the sludge is thereby disposed for the sludge treatment. Then comes the secondary treatment. Secondary treatment is a biological stage of wastewater treatment that aimed at removing the dissolved and the suspended organic matter by using the microorganisms. It relies on microorganisms, mainly the bacteria, that break down the organic pollutants naturally present in the wastewater. This state significantly reduces the BOD level and help they makes the water safe for the further use and the treatment. So there are two types of methods of secondary treatment. The first is the attached growth system and the second is the suspended growth system. In the attached growth system, the biomass is there attached to the media. Basically, media, we can say there is a platform of like rocks or plastics where the bacteria grow, and after that the wastewater is passed through this media and the clarification happens. For example of this is the trickling filter. And the next is the suspended growth system. In this, the microorganisms are suspended and mixed with the wastewater. Means there is no any the media for the uh, microbes at which they are spreading. Basically, they are mixing with the wastewater, and the entire biomass is in suspension and is treated in aeration. The example of this suspended growth system is the activated sludge process. So here is the This is the typical diagram of a secondary treatment. Here the raw sewage is coming from the primary treatment. Here is the aeration tank in which the microbes or the wastewater is mixed, and from here the air is being transported to this tank. After that, when the uh, organic matter is decomposed by the microbes, it is then transferred to the secondary clarifier where the sludge is settled at the bottom by the influence of gravity, and the clean wastewater is uh, released out of the treatment plant, and from here some part of the sludge is returned back to the aeration tank so as to improve its efficiency, and that is about 30% of sludge is taken, and and apart the other sludge is gone for the sludge treatment and disposal. Now let's talk about the trickling filter, which is an important method that is used in the secondary wastewater treatment. A trickling filter is a type of fixed film biological treatment system. It is called the fixed film biological treatment because microorganisms grow on a solid surface rather than being suspended in the water. In this system, the wastewater is sprayed or distributed over the bed of a coarse media like the stones or plastics, and the where water is aerobically treated by the microbial communities that are attached to the media. Now let's look at the components of a trickling filter. First is the filter tank or the reactor vessel. This is the main container where the trickling filter process happens. This tank is usually circular or it may be rectangular. Its size depends on the treatment capacity. The second is the filter media. Basically, this is the surface area for the microbial growth. This is the filter medium here, and the depth is typically 1.2 to 3.6 meters. Types, there are two types: the traditional media that includes the crushed rocks, the gravels, and the slab, and the modern methods that include the plastic modules, synthetic cubes, etc. Now, the third is the rotary or the fixed distributor arm. This component is mounted at the center of the circular tank. Its function is to spray or evenly distribute the wastewater over the filtering media. If a rotary arm, it moves with the help of the hydraulic pressure generated by the incoming wastewater. The nozzles or the holes on the arm ensure the uniform flow or distribution, which is critical for effective microbial activity. The fourth is the underdrain system. It is located at the base of the trickling filter. This system collects the treated effluent and it allows the air circulation from below. Now, the fifth is the recirculation pump. It helps in maintaining the microbial activity by reintroducing the part of the effluent. So here is the diagram of the trickling filter. This is the rotary or the fixed distributor arm. In this, the nozzles and holes are spraying the wastewater over this media. Influent is coming from here. This is the under drain system where the treated effluent is collected and is released from here. So this is the entire process of the trickling filter. So basically, this figure represent a typical, or we can say the conventional trickling filter. Here, this is the rotary distributor arm, which have nozzles or holes in it, which helps in spreading of the wastewater onto the media. This is the filter media where there is a rock layer of rocks or the plastic sheets in which the microbes are the growing. This is the filter support. This is the collection tank where the treated wastewater is stored, and from here the influent is coming. From here the influent is coming. It is spreading via this rotary tube, rotary disc, you can say. Here, when this water flows on this filter media, the microbes react or decompose or degrade the organic pollutant, and that clean water comes here at the bottom and is removed via this. So working principle of trickling filter is as follows. The wastewater is sprayed over the top of the filter bed. As I have discussed earlier, as it trickles down through the media, it contacts with the biofilm growing on the media surface. The microorganisms like bacteria, protozoa in the biofilm, they metabolize the organic matter. That metabolized water, or we can say the treated effluent, is collected at the bottom. Then after that, it is carried along with the biomass is carried along with the effluent to a clarifier or the settling tank, and the air is circulating from the bottom to top, providing oxygen for the anaerobic degradation. There are various types of trickling filter. The first one is the low rate trickling filter. Here, the water is coming from the primary sedimentation tank and goes into the trickling filter or is treated by the help of a trickling filter. After that it goes to the secondary sedimentation tank where the biomass settle at the bottom under the influence of gravity, and the clean water is disposed to the river. And the second is the high rate trickling filter. In this, the water is or the influent is coming from the primary sedimentation tank to the trickling filter, then to the secondary sedimentation tank, and the part of a sludge is returned back to the again to the PST. So as to enhance the efficiency, so as to enhance the removal capacity, and the treated wastewater is disposed by this. Now the third is the high rate. In this, the water is coming through this primary sedimentation tank to the trickling filter, and some part of the water is recirculated back. And after in the secondary sedimentation tank, some part of the sludge is also returned back to the PST. Then comes the two-stage trickling filter. In this, the water is coming from this PST to the trickling filter, and basically in this we are using two trickling filters and one secondary sedimentation tank. So after this secondary sedimentation tank, again the water is recirculated to this trickling filter, and the sludge is also returned back before the PST, so as to increase the efficiency, so as to degrade more and more organic pollutants from this type of trickling filter, as you can develop according to you the designs. Now comes the factors affecting it. The first is the hydraulic load. It refers to the volume of wastewater applied per unit area of the filter per day. It is expressed in meter cube per meter square per day. Its typical range is 20 meter cube per meter square per day depending on the filter design. High hydraulic loading led to the filter flooding that reduced the treatment efficiency, and its formula is Q by A, where Q is the total flow in meter cube per day and A is the surface area in meter square. Now is the organic BOD load. It refers to the amount of organic matter applied to the filter media, expressed in kg BOD per meter cube per day. High load require recirculation to avoid overloading and ensure the effective biological degradation. This organic BOD load, the formula is Q into BOD by V, where Q is the flow, BOD is the influent BOD in mg per liter, volume is the volume of media, that is meter cube. Now comes the recirculation ratio. It is defined as the ratio of recycled flow to the raw wastewater, or we can say the ratio of the return activated sludge to the raw wastewater. Mathematically, it is R is equals to QR by Q, where QR is the flow rate or the return activated sludge and Q is the influent flow rate. The ratio typically ranges between 0 to 3. It depends on the treatment system design and the load conditions. Maintaining the right recirculation ratio is essential for the process of stability, microbial balance, and efficient BOD removal. Now the third is the efficiency. It depends on the design, like you are using whether low rate or high rate, the media type, loading, and the recirculation. The low rate trickling filters have removed 75 to 90% BOD. High rate trickling filter with recirculation removes 65 to 85% BOD, and efficiency decreases if overloading or clogging occurs. Formula is E is equals to Si minus Se upon Si, where Si is the influent BOD and Se is the effluent BOD into 100. Now let's talk about the advantages. The first is the low energy consumption. One of the key benefits of this system that it does not require energy intensive aeration blowers. The natural or forced ventilation is done. Now the second is the simple operation and maintenance. The system have fewer mechanical parts which simplifies both their operation and the upkeep. Third is the stable performance. Trickling filters are known for their ability to handle the fluctuations in the organic load well. The fourth is the low sludge production. Compared to the activated sludge system, trickling filter produces less excess sludge. The fifth is the robust. This system is quite resilient and can tolerate the toxic shock loads better than some biological system. The sixth is the cost effective, especially suitable for small to medium sized communities. Although trickling filter have many benefits, but there are some limitations to be considered. The first is the odor problems. It can arise if the system isn't properly ventilated or maintained. The second is the fly nuisance, especially the filter flies can attract the trickling filters like the cycota. The third is the clogging risk. There is a risk of clogging due to the biomass buildup on the media. The fourth is the lower BOD removal compared to the activated sludge, particularly for high strength waste. Temperature sensitivity, its performance drops in the cold climate. Large footprint, it requires more space as compared to the compact systems. Thank you.